multiply using special products. Here we have 3 more examples of some products, but these look a little bit different from the ones we saw before. The ones we saw in the first set had a sum and a difference, but in this case we have a sum being multiplied by itself, a sum being squared, which is the same thing. Remember, when we square something, we're multiplying it by itself, and again a sum multiplied by itself. This is still going to be a special product, but it uses a different formula. So if we have a sum, f plus L, times itself, f plus L, unfortunately, the outer and inner terms don't cancel. However, they will combine in a special way, and we get f squared plus 2fl plus L squared. This means we take the first term and square it, we double the product of the terms, and then we take the last term and square it. This is another shortcut that allows us to multiply these special products without having to go through and FOIL things out. Let's see how it works out. Let's look at a plus 9 times a plus 9. I guess my a's look a little bit like 9s. I need to make sure they don't match up. So here, this fits the formula because we have a sum and it's being multiplied by itself. But instead of FOILing, let's try and use the formula to find the answer. It tells us first to take the first term and square it. Well, if we take a and square it, that gives us a squared. Next, we're meant to double the product of the first and last terms. Well, the product, a times 9, gives us 9a, and if we double it, that gives us 18a. Doubling is just multiplying by 2. And then finally, we need to take the last term and square it. 9 squared is 81, and so we end up with a squared plus 18a plus 81. It's a little bit shorter than FOILing. It saves us one step, the step of combining like terms, but getting used to this is going to be really helpful in later math classes. So let's get some more practice. Next, we have b plus 4 squared. Now we know that when we square something, we're multiplying it by itself, so this is really the same as b plus 4 times b plus 4. These are equal to each other, and so we've got a sum times itself, and so just like the last one, we can use this special product. We're told to take the first term and square it. If we take b and square it, we get b squared. Then we need to add double the product of the first and last terms. The product of b and 4 is 4b, and if you double it, that gives you 8b, so the next term is 8b. And then finally, we have to take the last term and square it. 4 squared is 16, so we end up with b squared plus 8b plus 16. We would get that regardless of whether we started off with b plus 4 squared or if it was written b plus 4 times b plus 4. I guess let's box in that last answer as well. And then finally, we've got one more, 5c cubed plus 3 times 5c cubed plus 3. This fits the pattern as well. We've got a sum of two terms times itself. Let's see how quickly we can use the formula. We've got to square the first term. 5c cubed, if we square that, gives us 25c to the 6th. 5 squared is 25. C cubed squared is c to the 6th. Then we've got to add double the product of the first and last terms. Well, 5c cubed times 3 is 15c cubed. And if we double that, that's 30c cubed. And we end by taking the last term and squaring it. 3 squared is 9. So we've got plus 9 at the end. And we end up with 25c to the 6th plus 30c cubed plus 9. I recognize that this is a little bit more work than the last one that we did, where we had a sum and a difference. But I promise you, if you get good practice with these, not only will they get easier, but this will be more helpful later on in Math 60 and in calculus.